For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below.
In this video, I'm going to show you how to find the length or the norm of a vector. First, I want to teach you how to derive the formula, make sense of it. So the way that you can do this on any exam, like you forget the formula, what you do is just draw a vector. Literally just draw a line like this. Label it, I don't know, vector v, whatever you want to call it. And then draw your coordinate plane in R2, so your second dimensional space of all the numbers. And then the first thing you have to know in terms of notation is that when we want to find the length of a vector, we're just trying to find what this is. Like, what is that? And we denote that as v with double absolute value signs, just like that. So this means, hey, this is the length of the vector v. I want you to give v just random coordinates, some easy ones. So let's say that v is equal to 1, 2. So that means that we go 1 to the right, so over here, and then 2 up, so 1, 2 up. What this means is that if you go 1 to the right, this length here is 1, and if we go 1 to the right and then 2 up, this length right here, this line, is 2. And then from here, you can use the Pythagorean theorem. So you can say a squared plus b squared is equal to c squared. Remember that your c is always your hypotenuse, and your a is the bottom, and b, the way I like to remember it, is b has a long line, and so is this a long line, vertical line, so this is b. So then we can say that 1 squared plus 2 squared is equal to c squared, and c is this. And then if we are saying that this here is equal to the length of a vector, and we're trying to find the length of a vector, then we want that by itself. So to get this by itself, I just have to take the root of it, because I know that if I have a square, the inverse operation is the square root. These cancel out, but whatever I do to one side, I have to do to the other. So then I'm left with the fact that the length of my vector v is just equal to the square root of 1 squared plus 2 squared. And I can simplify this to be just 1 plus 4, which is just the square root of 5. So I'm saying that the length of this vector is just the square root of 5. But the point here was just to show you how to derive the formula. So for any vector that you're given, literally like right now, I can say let u be equal to 3, 4. The length of u, this is how we denote length, will always be equal to the square root of the sum of the elements inside the vector, but squared. So all you do is take these, square them, and add them together. That's it. So 3 times 3, that's 9. 4 times 4, that's 16. 16 plus 9, that's 25. So you have that the length of your vector u is equal to the square root of 25, which is just 5. So you have a vector u, and you're saying that this here is 5. Let's say I ask you to find the norm or the length of this vector. So you have a vector w, and you just want to know, hey, what is this? What's the length? Remember, we denote the length as double absolute value signs of w. And that is equal to the square root of just you taking every single term from your vector, squaring it, and then adding them. So 1 squared is just 1, 2 squared is just 4, 3 squared is just 9. Remember taking the square root of that, that's 9 plus 4, that's 13 plus 1, that's 14. So this is the square root of 14. So the length of w is just the square root of 14. And that's it. So the whole point of what I did in the beginning was just in case you forget the formula, that it's literally just a square root, and then you just score the numbers inside your vector and add them together. You can always just start with a random vector, pick like small points, remember the Pythagorean theorem, and then just derive the formula. Now, the more formal definition is that the length of a vector v whatever is actually equal to the square root of the inner product, that is v times v. So if you have a vector v is equal to 1, 2, then to find the length, that's equivalent to saying, hey, let me find the inner product. 1 times 1, that's 1. 2 times 2, that's 4. 1 plus 4, that's 5. So this is square root of the inner product, that is 5. Because if the inner product, that is v times v, is this, and this is 5, then it's equal to 5, right? And that's exactly what we got. But the reason we just say, okay, take the square root and then square all of the numbers inside is because that's exactly what we're doing. These are the same numbers. You're multiplying by the same numbers. Instead of 1 times 1, just say 1 squared. Add, and then instead of saying 2 times 2, which is 4, just say 2 squared. So this becomes 1 plus 4, and that's 5. And this is exactly what we have over here. So it's just different ways of thinking about it, but I want you to be aware of both of the ways. And that's it for this video. I'll see you in the next.